Not infrequently, large fossils of animals and plants, especially tree trunks, are found which extend through several different strata, supposedly separated by millions of years. In 1993, the Mississippi River flooded. It dumped up to 6 feet of sand in different areas, and it completely demolished forests and farm fields, killed millions of trees, and what you found after that were a lot of new polystrate tree trunks. What it proves is that these tree trunks and these polystrate fossils, they're formed by rapid sedimentation and rapid flooding. They've actually found, and it's not just one case, they found multiple cases where you have whales that are vertically oriented in the fossil record, which means, you know, of course we know whales don't swim up and down very frequently. I mean, they may come up for air, but I mean, for it to be buried, it would have to be buried very quickly. Modern whales are 80 to 90 feet long, so you can imagine how many strata that would have had to go through. They found other whales that are 440 all the way up to 600 feet above sea level. So at some point, sea level had to be a lot higher. This is a graphic depiction of the layers that are found in Earth. You've got the asthenosphere, mesosphere, and all that. And the lithosphere is essentially the crust. That is the part that we walk on. What they have found, there is a scientist, and he has the best, most reputable model on catastrophic plate tectonics in the world. Even secular scientists agree with him. His name is Dr. John Baumgartner. And if you're not familiar with plate tectonics or subduction, essentially what happens is you've got the Earth's crust. We are all essentially on top of liquid magma. We're constantly moving a little, but we can't feel it because it's so subtle. But you have one plate that goes underneath the other one. It becomes magma. And so, believe it or not, our continents are constantly moving. What he found, if you look at the Mesozoic era in time, there is no pre-Mesozoic ocean floor left today, which means it was all subducted. It was all sucked back down into the mantle and reheated. And what he found is that subduction, this can increase exponentially based on heat and based on gravitational potential energy. So during the flood, when you had this huge mass of water like rapidly cooling the environment and the sea floor, you can actually have what he found is in subduction, instead of today's rates of a few centimeters a year, you could have meters per second during the flood. So all of this movement was occurring underneath the water during the flood. What they found is that in every continent in the world, there are evidence of large amplitude tsunami waves. Tsunamis are caused by huge earthquakes. There is sedimentary rock found on every continent in the world, which means every place has been submerged at one point in time. And this is one very interesting thing is when they take core samples of the ocean floor ridges, what they find is rapidly changing magnetic polarity, which means the internal currents of the Earth itself were rapidly changing and moving around. These are the seafloor ridges. As you can see, our continents, if we were to push them back together, they line up with that. They broke apart from that. And it's these areas that they took core samples from and found such, rapid magnetic polarity changes. This is, I think, one of the best evidences for a global flood. This is, they've taken seismic images of underneath the Earth's crust, and this is the mantle. The blue is colder mantle, the red is hotter mantle. If the Earth is billions of years old like they say it is, this should all be one temperature. But the fact that they find a relatively cold mantle versus relatively hot mantle means that within the past few thousands of years, you've had a subduction of a lot of the Earth's crust. It lines right up with John Baumgartner's findings, and it lines perfectly with a global flood occurring at some point. Some people have tried to say that the Grand Canyon was formed over millions of years by a slow trickling river, a creek. I don't see that happening. And there is a lot of evidence that canyons can be formed in a very rapid time period, a very small time period. The Snake River Canyon, Montana Badlands, etc. These are all canyons that were formed in a very small period of time. There's a canyon on Mars that is 3 times the size of our Grand Canyon, and scientists believe it only formed in 3 weeks. So why don't they believe that our Grand Canyon could have formed in just a matter of days or weeks? There's a modern example. There was a flood in Texas in 2002. It stripped the creek bed of all the trees and the soil. It started chewing into the rock below it, and it cut a canyon over a mile long, 20 feet deep, and 180 feet wide. And you can see how many cubic meters of material that it pulverized. And that only happened in 3 days. This is kind of an interactive thing here. Based on what you've heard about modern ideas of sedimentology and how layers are formed, you've got a layer here, and a layer here, and then the top layer. How much time do you think each one of these layers took to form? And this is a woman standing here for perspective. Any guesses?
Don't say, Josh, because you already know.
Because I know.
We watched.
Don't be shy. Any guesses at all?
30,000 years.
30,000 years, okay. Anyone else?
Tell them, Josh.
No.
He doesn't remember.
This bottom layer formed in only 6 hours. The middle layer formed in a day, and the top layer formed in a day. These were essentially, Mount St. Helens erupted, and it led to all this ash and lava flow leading to these different layers. But it's a direct representation, demonstration that layers can form in a matter of minutes, hours, and days, and have no indication of how long it took for them to form. This is a really interesting thing that I found. Lamina and strata, essentially layers in the geologic column, they form automatically in water. If the water is standing, let's say you take a cup that's filled with sand and silt and dirt and different sediments of different sizes, you start pouring it into water that is sedimentary, it'll automatically start forming layers. And what they found is that in moving water, based on the rate of the water, how fast it's flowing, you can actually, what you get is not layers forming from bottom to top, but from side to side. And I've actually got a video that I want to show you all for that, so bear with me for about a minute. Let me get this set up here.
Started at 1 meter per second and gave rise to a deposit of microstrata or laminae.